Imagine this incredible civilization, the ancient Maya, famous for these amazing pyramids, brilliant engineering, a really vibrant culture.
Still fascinates us, doesn't it?
Totally. But then picture it just fading away. Grand cities left empty, complex systems just stopping.
Yeah.
How does a society like that, seemingly so advanced, fall apart so suddenly?
It's the big question, the one researchers have wrestled with for ages. For a long time, people pointed to, local wars, maybe invasions, even disease outbreaks.
Right, the usual suspects in history.
Exactly. But there's always been this nagging feeling about climate, especially for societies so tied to farming. I mean, imagine your entire world depends on the rains coming at the right time.
And that's precisely what we're diving into today. We're going beyond those more general ideas and looking at some really cutting-edge research. He uses, well, you won't believe it, a stalagmite from a cave.
Yeah, sounds unlikely, but it's giving us this incredibly sharp picture of climate's role, specifically drought, in this whole Maya story.
So our mission here is to unpack the details of these ancient droughts, really understand how they hit a farming society like the Maya, and look at how different cities actually responded to that pressure. Because it wasn't the same everywhere, was it?
Not at all. Different places, different outcomes.
Okay, so let's just quickly set the scene.
Yeah.
The classic Maya decline, we think it started around the 8th century CE.
Common era, yeah.
And then over the next couple of hundred years, things really unraveled. You see major cities abandoned, those iconic pyramids just left, their really sophisticated water systems failing. It all just kind of ground to a halt.
It's a dramatic picture. And while we've sort of known climate had to be a factor, this new work really gets specific about why it was so critical, especially thinking about their main crop, maize.
Okay, so this is where the new study comes in, the one in Science Advances.
Yeah.
Based on a stalagmite?
That's the one, from the Zabna Caves, right there in the Yucatán Peninsula. Not far at all from huge Maya centers like Chichen Itza and Uxmal.
Stalagmite. How does that even work? How does a rock tell you about rain?
Well, it's pretty neat, actually. Stalagmites form super slowly. Water drips from the cave ceiling, carrying tiny bits of dissolved minerals. Each drip leaves a little deposit, and over, hundreds, thousands of years, it builds up layer by layer. Kind of like tree rings.
Okay, so each layer is like a year.
Roughly, yeah. Each layer traps information about the environment at the time it formed, especially about how much water was dripping, which relates directly to rainfall outside the cave.
You said this study was revolutionary, though. What was the big leap forward here?
The precision. Older studies might give you, say, an average rainfall for a whole year, or maybe general wet or dry periods.
Right.
This team managed to track rainfall changes almost month by month. Think about that. It's like having a daily weather diary from over 1,000 years ago.
Month by month, from a rock. How on earth did they do that? That sounds incredibly difficult.
It involves some clever chemistry. They analyze oxygen isotopes within those tiny layers. Basically, in years with less rain, the water that does manage to seep into the cave has a slightly different chemical signature. It's a bit heavier, isotopically speaking.
Heavier isotopes mean less rain?
In this context, yes. That distinct signature gets locked into the mineral layers as they form. So by analyzing the isotopes layer by layer, they can reconstruct past rainfall patterns with really remarkable detail.
Okay, wow.
And the lead author, Daniel James, points out why this matters so much. Maize, their staple, needs rain throughout the wet season. Being able to isolate that season lets them track drought duration accurately. That's the key thing, how long the dry period lasts, which tells you if the crops make it or fail. It's not just total annual rainfall.
Gotcha. It's the timing and the length of the dry spell that's critical for farmers.
Yeah.
Makes sense. Okay, but I read there was a weird gap in this stalagmite record, like 50 years missing, between 1021 and 1070 CE.
Yeah, that's a curious bit. There are two main ideas floating around. Daniel James wonders if it got so dry.
Like super drought.
Exactly. So dry that the dripping just stopped altogether for about 50 years. No drips, no growth.
Okay, that's one possibility. And the other?
David Dominguez, who's an expert on these cave formations, suggests the opposite could be true. Maybe it rained too much, causing the water to actually dissolve the top of the stalagmite instead of adding to it.
Huh. So either extreme dryness or extreme wetness stopped the record. That's fascinating in itself.
It really is. A little mystery within the big picture.
All right, so putting the gap aside, what did the parts they can read tell us? What was the scale of these droughts?
It's pretty sobering. The study looked closely at the last 200 years of the Classic period, so about 870 to 1100 CE. and they found at least 44 years within that time frame suffered from what they termed extreme droughts.
44 years out of 200. That's
Yeah.
a lot. What does extreme mean here? Like a
Right.
dry summer?
No, much worse. Their definition was 3 or more years in a row where the dry season dragged on for at least an extra 3 months. Or, even more intense, entire years where the rainy season basically failed to show up at all.
Wow. No rainy season. That's unthinkable for farming.
Absolutely catastrophic. And they identified specific major drought events. Between 870 and 1100 CE, there were 8 of these extreme episodes in Yucatan.
8 major droughts.
Yeah. The first really big one kicked off in 894 CE. It lasted 4 years. Then there was a single normal year, just one, followed by another 5 consecutive dry years. So you're looking at almost a solid decade of intense water stress right there.
That's brutal. A whole generation growing up with that kind of instability.
But wait, it gets worse. The longest drought they found. A staggering 13 consecutive years of unusually low rainfall, from 929 to 942 CE.
13 years straight.
13 straight years. According to their data, that's the longest drought on record for that region. Not just before Columbus, but even comparing it to the century since. Nothing else like it.
13 years? I can't even wrap my head around what that would mean. And this isn't just based on this one stalagmite, right? They cross-referenced this.
Oh, yeah, definitely. That's crucial. These precise dates line up really well with data from other stalagmites in the area, and also with sediment cores taken from lake beds. It builds a consistent picture.
Okay.
And what's really compelling is that this climate timeline matches the archaeology. You know, the inscriptions the Maya carved on stone monuments, the dates of major building projects, signs of political activity.
It all starts to drop off during these drought periods.
Exactly. At the big northern Maya sites, you see a clear slowdown or complete halt in things like monument building right when these droughts were hitting hardest. The stones themselves seem to confirm the climate stress.
So the evidence seems pretty strong. These weren't just bad years. They were civilization-shaking events.
Yeah.
How did the Maya cope? I mean, they were sophisticated, right? They had water systems.
They absolutely did. But their whole agricultural base, maize, beans, squash, was fundamentally vulnerable to rainfall patterns. A short drought, maybe a few months, a single bad wet season. They could probably tighten their belts, use stored food, maybe trade. There'd be hardship for sure, but likely survivable.
But these multi-year droughts.
These extreme multi-year events, the study suggests crop yields could plummet to maybe 1/10 of normal, a 90% reduction. No society, no matter how organized, can sustain its population through that for long.
And we see different cities reacting differently. You mentioned Uxmal earlier.
Yes, Uxmal seems to be a clear case where the decline mirrors the droughts. The dated inscriptions there run from about 895 to 907 CE. Monument building peters out in the early 900s.
Right when those first big multi-year droughts were hitting.
Precisely. It looks like the constant pressure, the lack of recovery years just destabilize things. Their political system seems to collapse around 950 CE, which is just 8 years after that monster 13-year drought ended. It suggests even their, quite advanced water storage reservoirs, cisterns, just got overwhelmed.
But then there's Chichen Itza. It tells a different story, at least for a while.
It does, and it's fascinating. While parts of Chichen Itza, the older parts, declined along with other cities, the area known as New Chichen actually seemed to thrive for a bit longer, right through some of these tough periods.
How? What made them different?
Well, the thinking is they had much more extensive trade networks. They were highly centralized. This might have allowed them to stockpile resources or, crucially, import food or trade for other necessities during local shortages. Maybe they traded other goods for maize brought in from, say, central Mexico, where the climate might have been different.
So a more diversified economy, with better connections?
Possibly a different kind of societal organization that provided a buffer. But, and this is important, even Chichen Itza eventually hit a wall. It declined significantly in the early to mid-1000s CE during another major drought phase, often called a mega drought.
So resilience bought them time, but even they couldn't withstand the climate pressure indefinitely.
It seems that way. Even the most robust systems have breaking points.
Which makes sense. But I gather there's still some debate about how resilient the Maya were overall. Not everyone agrees. This study tells the whole story.
That's right. You have scholars like Scott Fedek, professor emeritus, who argues this focus on maize might underestimate Maya resilience.
How so?
He points out they didn't just eat maize. They cultivated a whole range of perennial food plants, things that live year after year. These wouldn't fail as quickly as annual crops like maize. They'd handle moderate drought better and decline more slowly, even in severe conditions.
So like a backup food source.
Exactly. He thinks these perennials could have provided a significant food security buffer that maybe gets overlooked if we only focus on the most vulnerable crops. It's a fair point about dietary bread.
Okay, that adds another layer. And then there's Rafael Cobos, a historian.
Yes, and he offers a somewhat different take. He actually suggests that both Uxmal and Chichen Itza kind of reached their peak development and then declined around the same time, towards the end of the 11th century, right in the thick of that really intense drought period.
So less about Chichen Itza's special resilience and more about a shared vulnerability.
That's his interpretation. His conclusion is pretty stark, really. He argues that ultimately Maya civilization was so reliant on maize agriculture that it simply could not sustain its large population when faced with these prolonged, severe droughts, leading to collapse, social, political, economic, even in the seemingly stronger centers.
It emphasizes that fundamental link between climate, water, and food for them.
Absolutely. And we know the Maya were smart. They adapted. They built reservoirs, cisterns, used terracing, maybe even adopted more drought-resistant crops like manioc in some areas.
They weren't just passive victims.
Definitely not. And those strategies clearly worked, probably helped them weather numerous smaller droughts over the centuries. But what this stalagmite data really drives home is the sheer grinding intensity and recurrence of the droughts during the Terminal Classic period.
It suggests they were hit with something beyond what even their clever adaptations could handle.
That seems to be the implication, that the environmental stress just kept coming, blow after blow, overwhelming their capacity to cope. It pushed them past a tipping point.
So wrapping this up, this deep dive really paints a powerful picture. Climate change, specifically these really severe, multi-year seasonal droughts, played a huge, complex role in the Maya collapse.
It wasn't the only factor we should stress. Politics, warfare, resources, they all played a part.
Sure, but the climate stress seems to be this massive underlying pressure. It shows even a really advanced society, one with smart water management, could be brought to its knees by persistent environmental change.
And the different responses, like Uxmal versus Chichen Itza, show it wasn't monolithic. Resilience varied. But ultimately, the pressure was immense. For me, the key is that duration, that 13-year drought revealed by the stalagmite. That's the kind of detail that changes the conversation.
It really does, and it feels incredibly relevant today, doesn't it?
Absolutely. The predictability of rainfall is still vital for farmers in that region and across the world. Declining predictability is a huge modern concern.
And you mentioned later historical famines.
Yeah, even in the colonial period, centuries later, droughts like one in the mid-1600s caused terrible famine and huge population loss among the surviving indigenous Maya communities. It shows that vulnerability to prolonged drought didn't just disappear.
It's a stark reminder. What really strikes me is how much we learned from, well, a rock formation in a cave.
It's amazing, isn't it?
If climate data locked away in a stalagmite can give us this kind of detailed insight into an ancient civilization's struggle, it really makes you wonder, what other secrets are hidden in natural archives around the world? And maybe more importantly, what lessons do these ancient struggles hold for us now, facing our own changing climate?